Okay, so we're looking at an algebra unit and it's solving linear equations. And again, excuse me, you would have done this before, but we'll just go back a few steps. So a linear equation is a mathematical statement of two equal expressions. Now what that means is a little bit confusing at this stage, but when we look at some examples, you'll see. The variable is the letter. Okay, the variable is the letter of the alphabet representing a number, and it may appear more than one time. Okay, and the variable can only have an index of 1. Okay, and again we'll have a look at some examples on the next page. And the other thing you have to know is linear equations have one answer. Okay, you can't have two answers. Okay, so let's have a look and see what this means. Okay, copy that down and then come across when you're ready. Okay, so if I've got 2x plus 3, okay, the letter x is the variable. Okay, and if I've just got 2x plus 3, that's an expression. Okay, it doesn't have an answer. You can't add them because they're unlike terms. It's not an equation. Okay, it's just an expression. But if I put an equal sign and have something on the other side, this is also an expression. 6 is an expression. So I've got two expressions separated by an equal sign, and now I have an equation. Now I have an equation. So the variable is x. Okay, it has an index of 1. There's a 1 there. So, and the variable just appears once. Okay, so 2x plus 3 equals 6 is a linear equation. There will be an answer. I'm not worried what the answer is at the moment, but that is a linear equation. Whereas 2x plus 3 all by itself is an expression, okay, not an equation. Okay, so copy that down when you're ready to come across. So if I have 2x plus 3 equals x plus 6, I have one expression and I have another expression, so I have two expressions separated by an equal sign, so I have a linear equation. The variable x, okay, the variable x has an index of 1, okay, there's a 1 that you don't have to write in. The x has it's an index of 1 and it appears twice. Okay, you can appear more than one time. You can't have more than one equal sign, but I could have x plus 3 plus x plus 5 equals x plus 8. No, actually I can't have x equals 8 because that would be 0. I could have 0, but x plus 10. So I could have the variable x appearing 3 times and it's still a linear equation. Okay, you just have to have an equal sign in between two expressions. Okay, so copy that down and when you're ready, come across. Okay, so let's have a look at what are not equations. So x squared minus 9 is not a linear equation because the variable x has an index of 2 and you can't have anything bigger than 1. Okay, so it is an equation, but it's not a linear equation. The next one, so that's the first one. Okay, the second one, there are two variables, okay, so it's not a linear equation, okay, because there's two different variables. You can only have the same variable appear, like x and x, okay? That's a different sort of equation. It might lead to simultaneous equations, or it might be an equation called a Diophantine equation. In the third one, okay, because I've got the variable x appearing twice, I have to look at it separately. Now, this one has a power of 1, but this one has a power of minus 1 because it's on the bottom, okay, and minus 1 is not equal to 1, okay, so we have a not linear equation. If I had 1 over x equals 5, which I won't do right now, that actually is a linear equation because I could turn both numbers, I could turn both things upside down. So x over 1 equals 1 over 5. So this one is not the same as that because I have the variable appearing twice. Okay, so this one here, you can actually turn that into a linear equation. Copy, and when you're ready, come across. Okay, so before we go on to some one-step equations, I just want to remind you about some addition and subtraction rules, just in case you forgot, because this is where you can get into trouble. So I've got, actually I'm going to change that to a plus sign there. Okay, so in this first one, if you have 5 minus 3, representing on a number line, you start from 5 and you subtract 3 and you end up at 2. So 5 minus 3 equals 2. But why I've done this is because you can get into trouble with negatives, and I just want to make sure you all understand. So if I've got 3 and I subtract 5, I'm going to use up 3. Of that 5, I'm going to use up 3 getting back to 0, and then I've still got another 2 to go. So 3 minus 5 is minus 2. Okay? Sometimes it's sometimes easy. If you know the answer is going to be a negative, 3 minus 5 is a negative, then you can just do 5 minus 3, the opposite order, and then just change the answer to a negative. So 5 minus 3 is 2, and you know the answer is negative, so it's negative 2. With this next one, minus 5 plus 2, okay, what I want to do is just prove that sometimes the answer is a positive, sometimes it's a negative. There's no rules, you've just got to look at the numbers. So minus 5 means you start there, and you use up, because we're adding is going up, and obviously subtraction is going down. Subtraction is going down. But if I'm adding 5, I use up 2 to get back to 0, and then I've still got 3. So the answer is going to be positive 3, and you don't have to write a positive sign. But this next one, minus 3 plus 1, I'm only going up 1, so I'm still stuck at a negative number. So there's no rules about negatives and positives make positives or negatives. You've just got to look at how big the numbers are. Okay? If the positive number is bigger than the negative number, then you've got a positive answer. But if the positive number is not bigger than the negative number, you'll still end up with a negative. Okay, so just be ready for that later on when you have the 1-step and 2-step equations. If you are confused about that, just just put your hand up and I'll come and see you. Okay, so what we're doing is we're looking at some 1-step equations. Again, you've done this before, so we'll just, again, you've been shown different ways, but I'll just show you hopefully a way it'll make sense. Okay, so what we've got, it's like we've got a balance beam, and we've got x plus 5 on one side, and we've got 2 on the other, and what we have to do is whatever we do to one side, we've got to do to the other to keep it balanced. So, you know, we can't take off things on one side and not take them off on the other. And what we're trying to do is we're trying to isolate x, so it's x is by itself and it doesn't have anything with it. So the easiest way is just to do the opposite. So if I've got plus 5, if I do minus 5, then plus 5 minus 5 cancels out, and so x will be 2 minus 5 is minus 3. So you have the answer. So if I put minus 3 up the top where the answer, where the box x was, minus 3 plus 5 equals 2. So the answer checks out. Okay, so I'm just going to pretend I'm doing a balancing act, and whatever you do to one side, you do to the other. So if you want to get rid of plus 5, you have to minus 5, and that cancels it out. With number 2, to get rid of minus 3, you plus 3. But if you plus it to the left, you've got to plus it to the right. And so to isolate x, minus 3 cancels out with plus 3. But on the right-hand side, 1 plus 3 doesn't cancel out, and the answer is 4. So that answer there could go back where the x was, and 4 minus 3 equals 1. So the idea is if you have a plus number, you just minus, and if you have a minus number, you plus. Okay, so the opposite operation. So all we're doing is keeping the balance between two sides. Now this 2x is not the same as a plus 2, it's a times 2. And to get rid of to isolate the x, we've got to get rid of the 2. And so rather than subtracting, because you can't, 2x minus 2 doesn't equal anything because they're unlike terms. But if I divide by 2, then the 2's will cancel out. But I have to divide both sides by 2. And so x is 7 on 2, which is 3.5, and it's also equal to 3.5. Okay. Just a reminder, I'll just go back a step. You really should put the triangle of dots, which means therefore as you progress down these equations. So therefore, 2x equals 7, therefore x equals 3.5, or 7 on 2. And in the last one, we've got two things. We've got a times and a divide. And if I put 5x on 3 again, like we did here, if we're trying to get rid of the 2, or trying to get rid of the 5, you've got to do division, but this divide 3, to get rid of it, is a times. So what's going to happen is that 5 will cancel out with that 5 and turn into a 1. 5 into 5 goes once. 3 into 3 goes once. So to get rid of 5 over 3, you multiply by 3 over 5, the opposite. But on the other side, that's the number that we've brought in as a new number. So we've got to multiply the other side by 3/5. And so x is isolated. So x is minus 2 times 3 is minus 6 divided by 5. Okay, and that's the answer as a fraction. And you could write it as minus 1 1/5, or could write it as minus 1.2, but that answer is just as neat. Okay, so that one there, the 5 on the top becomes a 5 on the bottom, the 3 on the bottom becomes a 3 on the top, and then you do both sides the same. Okay, and there's exercise 4A on page 108. Question 1 is just identifying linear equations. Okay, so they are or they aren't, and these ones are all just one-step equations. Okay, so in the next video, I'll fill in more examples to do with questions 3 to 5 and then the later questions. Okay, so if you can just do that to start with, that'd be great. Okay, thanks, bye.